All right, let's get started. Good afternoon, welcome. Thank you for coming. Quick show of hands, how many of you guys are attending re:Invent for the first time? Awesome, hopefully you guys are having a great conference. Anybody get a chance to attend Andy's keynote this morning? Awesome, good. So Andy mentioned we've released almost 1,000 new features and services this year, on pace to release 1,300 by end of the year. Wow. As much as we'd like to cover all 1,300 today, the next hour, good news is a lot of the concepts we apply, you can apply to most of the services within AWS. My name is Sunny Sunkara. I'm an Enterprise Solutions Architect with Amazon Web Services. And today with me I have Haider Abdullah, Cloud Architect at Hess Corporation. Really excited to have Haider here today to share the Hess team's experience around AWS optimization effort. There are many sessions at re:Invent this year on cost optimization. This is really unique in a sense that we're really focusing on the how and the deep and actually showing you how some of the optimization best practices that we work with our customers are actually implemented in the real world. So by the end of this session, we hope that you'll walk away with learning a bit about Hess, gaining insight from the migration journey that they've been on for the last couple of years, as well as gain knowledge from the recent AWS optimization strategies that they've implemented. We hope that you'll take away some strategies that you can implement at your organization right away. With that, I'd like to turn it over to Haider to start by telling us a little bit about Hess Corporation. Haider.
Thank you, Sunny. So for those of you that are not familiar with Hess, we're a large oil and gas company. We've been around for a very long time. If you've ever lived on the East Coast or worked or traveled to the East Coast, you've probably seen our retail gas stations that we used to have for many number of years. We were started by a single man, Leon Hess, with a single oil truck. And over the several decades to come, he grew that into a multinational corporation, a fully integrated oil and gas company doing upstream, midstream, downstream, retail, all of it. In the last few years, we've decided to transition away from being a fully integrated company and focus on our core competencies, which is exploration and production. And that was in the interest of delivering the most shareholder value to our customers and shareholders as much as we could. So with that, our current business looks like this. We explore for hydrocarbons all over the world, and one of our most recent discoveries is offshore Guyana. We are very happy to partner with ExxonMobil on that joint venture. We're also doing a lot of production work, both on the onshore as well as offshore. We have some of the most leading acreage positions in the North Dakota Bakken Shale Formation, and then in the offshore side, we also operate in Gulf of Mexico as well as other areas. One of the things that really sets us apart as an oil and gas company is our commitment to what we call a lean culture. And this is kind of a differentiator for us. So what is lean all about? Now, this is a topic that's too big to cover in a single slide, and I can't possibly do it justice. So I'll give you just a little hint of what I'm talking about here. We first came to apply this in our drilling and completions business. And you can see from the chart the results that we were able to achieve by applying it in that area. And we decided that we wanted to buy all in on this lean thinking and embed that in all areas of our organization, at all levels of our organization. So it's embedded in our performance management processes for our employees. We're graded on that, matter of fact. And the two things that I want you to take away from this talk about lean, if you've never really had much exposure to it, is one is to make problems visible, and two is to eliminate waste. Now, it might seem a bit odd that I'm talking about lean manufacturing principles at a cloud computing conference, but you'll see how this all fits in together as I go through the rest of my talk. Let me tell you a little bit about our experience with AWS. How do we come to find ourselves working in the cloud? Our first exposure to this was in one of the divestitures that I mentioned earlier. We divested the downstream business. We moved about 170 instances in 6 months. And then subsequent to that, a year later, we did a second divestiture of another business. We moved quite a lot of workloads again. We took a lot of learnings about how to migrate things, applied those to the second divestiture. And then finally, last year, we started migrating our core E&P business assets, which is our current environment, into the AWS cloud. So with that new effort, there are some additional challenges that we didn't have before. So when you're divesting something, you're moving the stuff out, and then you're handing it over, you're giving the keys to the kingdom to somebody else, the purchaser, right? And then you walk away. You don't have to worry about optimizing that environment, right-sizing that environment, operating it in a long-term basis. Now we've got 500 something and ever growing, right? We're still migrating. We're not done with this process yet. We've got all these instances out there. It includes Windows workloads, a handful of Linux workloads, SQL Server, Oracle, sad to say. But these are a combination of greenfield installations as well as using migration tools to export VM images to get them into AWS. So we've kind of done all sides of it. So with that, the rest of the talk, I'll talk about this new environment that we're in because we've had to develop the capabilities and develop the techniques to keep it running, keep it operational, keep it optimized and efficient all the time. How do we go about doing that? How do we achieve all those things? So I'll hand over to Sunny, and he'll take you through the AWS recommended approaches and techniques, and that's going to be the what you should be doing. And I'll come back up here on stage, and I'll share with you how in detail we applied all those techniques in our environment specifically.
Thank you, Haider. So I've had the pleasure of working with the entire Hess account team for the last couple of years through these migrations, starting with the second divestiture and the most recent one. Obviously, combination of lift and shift and refactoring, some of the cutting edge. And you'll hear from Haider later today how they've really embraced and how they've evolved in terms of the cloud journey that they've been on and how we begin to really optimize their environment. So when we talk about a journey to the cloud, what it looks like in terms of migrate, optimize, and automate, I think it's important to talk about a few terms here. How many of you heard about the CAF, the Cloud Adoption Framework? Okay, a few folks, good. So the Cloud Adoption Framework essentially offers a structure for organizations to develop an efficient and effective plan for their cloud journey. Similarly, there's another literature that we put out around the Cloud Transformation Maturity Model. How many people have heard about that? Yeah, a few folks. So the Cloud Transformation Maturity Model is a tool that you all can use to assess the maturity of your cloud adoption through essentially 4 stages: project, foundation, migration, and optimization. So if you take a look at the optimization phase, what are the key activities that we address there? So what are some of the transformation activities that need to be done in each of these areas? So we'll start with service management, right? Being able to utilize the latest AWS tools to continuously improve your service management methods and processes. Application management, right? Using AWS best practices, such best practices and tools such as DevOps and CI/CD to continuously improve how you manage your application development. Enterprise services, being able to continuously aggregate and improve how you're delivering shared services to your organization. And the cost management, of course, being able to leverage AWS tools and features to continuously improve your operational costs, right? Things such as consolidated billing, reserved instances, taking advantage of the discounts. Obviously, we'll be talking more in depth about cost management in the next hour. Finally, at the core of this, it's really important to incentivize teams to take ownership and invest the time to help them build the right skills. And you'll see how this played out at Hess. So moving on to cost optimization. We're only operating in a new IT consumption model where IT can be consumed on demand. So with this utility pricing model, everyone pays for what they use. If you think about it, it's like your water bill. If your faucet is running, you're paying your water bill at the end of the month based on what you used. But what happens if you leave that faucet running? you're still paying for all that unused water. So cost optimization is really about focusing on what is needed and identifying a way that we can turn the corner between usage and need to ensure that we are as efficient and lean as possible. So where do we start? There's so many levers that you all can take advantage of, but some have larger impact than others. Some require more engineering effort than others. So where do we start? What are the low-hanging fruit that we should focus on that will have the biggest impact on your next month's bill? So working with customers, we see those that are successful in this space pulling several levers consistently. So I'd like to focus on 5 levers that we focused on at Hess. First is about right sizing, being able to pick the right instances. Second is increasing elasticity, making sure that we're architecting our workloads to maximize elasticity. Third is picking the right pricing model. Fourth, matching usage to the storage class. And finally, ongoing continuous improvement around measuring and monitoring your environment. So let's talk about each of these in a little bit more detail. So it shouldn't be a surprise that we're talking about right sizing in a cost optimization conversation. Right? So what is right sizing? So it's essentially selecting the cheapest instance while meeting your performance needs. Today, AWS offers more than 90 instance types. Well, as of last night, I think it's more than 100 instance types. So there's a vast selection to choose from. And when you start overlaying the cost into the equation, it gets quite complex. But by looking at CloudWatch metrics, you can quickly identify candidates to downsize. Second is about increasing elasticity, being able to use when you need the resource and turn off when you don't. Sounds pretty simple, right? But customers that are early on this journey often struggle with operationalizing this. You know, this on-off mindset. But when you think about it, when it can give you up to 80% in savings, it really becomes a powerful saving mechanism. And then when you factor in things such as Lambda, event-driven compute, and serverless, it really sets you up for automated scheduling. Haider will talk about this in more detail, about how they've really excelled at operationalizing this concept and get their application teams to really buy into this on-off concept. Third is about leveraging the right pricing model. So being able to use reserved instances for your always-on predictable workloads and on-demand and spot instances for your spiky and variable workloads. With spot instances, you can get up to 90% savings. With Spot Fleet, you can maintain instance availability. And with Spot Block, you can use for workloads that need to run continuously. And as you've seen from last night and this morning, we're continuing to iterate on how we're rolling out Spot features with the Hibernate feature, as well as how we're addressing how Spot pricing transitions as well. Reserved instances. So it's not a surprise that it's a big part of this conversation. So reserved instances are such a commitment for 1 or 3 year basis for reserved capacity. In exchange, you're getting up to 75% savings. But you'll see there the return, the payback could be as little as 7 to 9 months for 1 year and 10 to 18 months for 3 years. It's also important to realize that RIs extend beyond just EC2. You'll see here across RDS, Redshift, Dynamo, as well as CloudFront. So when you start applying reserved instances across these other services, you can see how it becomes a real powerful discount mechanism for all of your workloads. And obviously, there's a new flavor of reserved instances that we released earlier this year with convertible reserved instances. that allow you to modify existing reservations across instance families, sizes, operating systems, and tenancy. So the first three pillars really talked about instance-based services, right? So EC2, RDS. Now let's take a look at storage. Let's take a look at block storage with our EBS service and object storage with S3. With EBS, it's important to realize that you can take advantage of the different EBS volume types to optimize even further, knowing that you can fully increase the size of your hard disks with a few clicks. Similarly, you can shrink volumes, albeit a different process, with zero downtime as well. Moving on to our storage service. With S3, it's really important to leverage the different storage classes and the S3 lifecycle policies to move your data across these classes. So with S3 infrequent access, you can get up to 60% of savings of the standard S3 storage cost plus retrieval fee. And with Glacier, you can get up to 80% savings of the S3 pricing per gigabyte. So we've talked about 4 pillars so far: right sizing, maximizing elasticity, right pricing model, right storage class. Sounds pretty simple, right? In reality, it's very complex when you factor in the scale, the behavioral change, the visibility this gets, and kind of the ownership that you need. This is really where the 5th pillar comes in: governance. The ability to measure and monitor your AWS environment. Here are a few common metrics customers typically look for, but you really have to look at which metric makes sense for your workload. AWS provides a few options for you to do this. With Trusted Advisor. Trusted Advisor helps you automate best practices through a series of checks on your AWS environment across cost optimization, security, fault tolerance, and performance improvement. You get access to Trusted Advisor if you're on business or enterprise support, and highly recommend you take advantage of that. Second is the Cost Explorer, which lets you visualize, understand, and analyze your AWS cost and usage over time. An important thing to realize is you can certainly use your own tools as well, as you'll see Haider talk about in his story. So to recap the 5 pillars: right sizing, increasing elasticity, picking the right pricing model, and matching usage storage class, and then governance in terms of ongoing continuously measuring and monitoring your AWS environment. With that, I'd like to turn it back to Haider to talk through how the Hess team implemented these as part of the AWS optimization efforts.
Thank you, Sunny. So Sunny went through a lot of the pillars that we had to get familiar with as we went on this journey to migrate all of our stuff and start operating in the cloud. I'll summarize a little bit the migration challenges that we faced once we found ourselves in this environment. The first thing we said was we're going to move everything. Nothing stays behind, if at all we can help it, right? So we wanted to exit the data center business. Our core competency is exploration and production, like I said. We wanted to take advantage of all the features that are available in the cloud. And so we did that. We started moving everything. And here are some of the challenges we faced around efficiency. When you have to convince a lot of people to move, when they have no familiarity with the cloud, it's completely new to everybody, a lot of times you make trade-offs, right? You agree to provision things maybe at a higher level, just because that's what they had on premise and they're used to that amount of capacity, you give them that capacity. Well, once you're operating in the cloud, you have to go back and address that. You can't just leave that out there forever because you're burning cash when you're doing that. You want to give visibility and transparency to all those IT owners. So we've got application owners at the manager level, senior manager level, who own significant parts of the estate, and they need to be able to see what their applications cost to run on a monthly basis. And we need to give them ownership of that resource usage, right? We need to make that easy in the current tool sets that they have. And then finally, from an operational kind of centralized function perspective, you have to have your hands around the things that you need to do on a regular basis to make sure the operation of the environment is as efficient and smooth as possible. You can't ignore security, obviously. Often, many of us do, because it's just a hindering block a lot of times for us, a stumbling block. And then one of the things that you always talk about going to the cloud is the agility that it offers you. So if we are now in the cloud, are we taking advantage of those features? Are we getting the agility that we promised to our end users? So let's talk about how we actually address these things. But just for a second, I want to focus on the provisioning challenge. Now, Sunny alluded to this earlier in one of his slides, which is, how do you know if you've got the exact right level of provisioning? So on this chart, you can see a typical scenario that is very easy to use to communicate. The solid red line indicates what your compute needs are for your workload, and then the dashed green line shows you what you've actually provisioned. So anytime those two lines don't match up, you've got a situation where you've either over-provisioned, and what that means is you've decided to pay more than you actually need for your workloads, or you've under-provisioned, and you've got dissatisfied customers because your workload is not getting the right level of compute that it needs, or storage it might be. So in today's environment, with our migration, we pretty much did, for the most part, a lift and shift type migration. So that means infrastructure as a service, EC2 instances, lots of them, right? So with EC2, can you solve this? Can you bring those two lines as close together as possible? It's not that easy. It takes a lot of effort. It takes a lot of discipline to do that. So what's the solution? How do you deal with this long term? So my personal feeling is serverless, right? That's the way to go. That's where you can actually get these lines to almost overlap as much as you can, very close to each other. But that's a long-term refactoring, re-architecting type of conversation. So what do we do today with the EC2 instances that we already have in the IaaS world that we're living in? We have some strategies that Sunny talked about, and I'll show you how we implemented that for today. But while I'm building out those tools and I'm building out those things, I want to keep my eye out on, am I building the capabilities for the future to take advantage of all these serverless things that are being offered by Amazon and by others? So let's just define serverless real quick. How many of you guys are using some type of serverless technology? There we go. Pretty good number. So this is another one of the buzz terms for a lot of people who've never seen or heard about this before, right? They're just confused by it. What do you mean serverless? There's always a server somewhere, right? It's running on something. Maybe I don't see it. And that's the point, right? So as a consumer, as an application developer, you're not concerned with the server. You don't care about provisioning a server. You don't care about patching it. You don't care about putting antivirus on it or taking care of it, making sure it's up and running or rebooting it or any of those things that we traditionally associate with a server. All you care about are the resources that you need. Do you need an email sending service? Do you need an API service? Do you need a compute service? Do you need storage? You just need to worry about that part of it. And you need to worry about just the parts that you actually can spend time and build real things with. And you let somebody else, in this case AWS, worry about the underneath the covers provisioning of all the resources required to make your stuff run. So that's the long-term strategy I think that everybody's going to start adopting more and more. We've certainly started adopting it in different areas. I won't drain the slide here by going through every single one of these. There's a lot of information about a lot of them. The core service out of all of the things that you see here is Lambda, which is the compute service. So I'll just do one slide on Lambda real quick. If you're not familiar with Lambda, it's basically a function as a service offering, right? So you write your code with your application logic, and they support Node.js, Python, .NET is supported as of last year. I believe Java is supported. So whatever skill set you already have in-house, whatever your developers are comfortable in, you write your code and you're concerned with the logic of that code. What do you want it to do? Then you upload that to AWS Lambda. And once you've uploaded it, you define the triggers that are going to kick off your code. And these triggers may be scheduled time-based events. You might want to run a function, let's say, every 5 minutes, once a day, once a week, what have you. Or it may be an event trigger, such as a person logging into a console, or an API call to AWS to start up a server or to terminate a server. And you want this function to run in response to that event. Then it'll run, and what you get is a bill based on sub-second metering. That is as close to matching those green and red lines as you can get for compute. So let's talk about what we did in terms of cost optimization. Here are our overall goals, right? We want to provision resources at the proper levels. We want to use them only when necessary, right? So if things are running in the middle of the night when there's nobody around, nobody's logging into the server, nobody's firing up a web app that the server might be hosting, why are we running it, right? We shouldn't be running it. We want to provide transparency to costs and waste. Again, going back to that lean principle I talked about at our company that we take very seriously, make problems visible. If you can't see the problem, how are you going to address it, right? That's our mantra here. And then we want to give self-service capabilities to our end users. As I mentioned earlier, part of the benefit of going to the cloud is agility, and what's more agile than being able to go out and request a new server if you needed it. And then a lot of the trouble is driving cultural change when you go on this migration, right? Because people are used to this just-in-case provisioning concept. In the old world, if you thought you were going to grow to use 5 terabytes of usage over time, you provision 5 terabytes right then and there because it was hard to go out and go get more now. But in AWS, you have live resizing of EBS volumes. You can start with the 100 gigabytes, 200 gigabytes, whatever it is that you need with some buffer for the near-term growth. And then as you need to scale out, you can scale out. Because EBS, for example, you pay for what you provision. So a 5 terabyte drive that won't get filled up for 3 years from now is completely wasted. So we have to drive that cultural change. So how do we address some of these things? So the first thing we did was we started building out some Spotfire dashboards. So for those of you that are not familiar with Spotfire, it's an enterprise BI reporting tool. People in our organization are very well familiar with it. They use it to slice and dice data all day long. You can create all kinds of stuff in it. And there are things that are in the AWS console, out of the box native that Sunny mentioned, Cost Explorer, for example, that are available to use. But that requires a login into AWS, right? That requires everybody to go in and learn how to use the Cost Explorer. And we wanted to stick with what people are already familiar with. So I can build a Spotfire dashboard and publish it out, and that can be saved in someone's bookmarks. It can be put on a SharePoint site as part of a web part, and they can go to it very, very easily. They're familiar with the controls on how to interact with the report. And I'll show you some examples of what some of those reports look like. The other thing we did was we implemented these on-off cost optimization schedules. And we aim to get as many of our servers onto these schedules as possible. It's a lot easier said than done. People have a lot of hesitancy about turning off their servers. Even in the middle of the night, you'll get a lot of resistance to that. So how do you combat some of that resistance? Well, one thing you can do that we did at Hess was empower our power users, who are developers and their managers, with IAM user accounts for AWS. And we used smart tagging on our resources so that the person tagged on the instance has the ability, just the ability for that one instance that they own or multiple instances that they own them, to go in and start up their servers whenever they want. So that gets over a lot of this hesitancy that you might get early on from people who will say, well, what if I need it? Okay, well, here's a login. Go start it up when you need it. We don't need to run it 24/7 just in the chance that you might need to log in at 7 o'clock and fire it up. It takes 5 minutes to bring it up. So we try to get people into that model of thinking, right? So we actually managed to get over 50% of our instances on some sort of a schedule. And the key thing with that is giving people the flexibility to pick their own schedule. So somebody might be working on a particular server from 8 a.m. to 5 p.m., and that schedule might work for that person. But that's not a one-size-fits-all, right? Someone else might be working 6 a.m. to 6 p.m., or you might have an offshore developer who comes in at completely opposite hours and needs them during Indian Standard Time, for example, right? So we worked with them to craft these custom schedules that work for their specific workloads in order to get more buy-in onto that. What were the results from that? Here's some of the numbers around savings. So for the set of servers that are actually on schedules, if we were to run them 24/7 versus what we actually run them on now, the amount we're saving is 75%. And as a percentage of the total estate, we're saving a third of our bill. That is a huge impact, right? And I'll show you the dashboards that we use to help kind of drive this adoption and keep bringing this trend in the positive direction more and more. And yes, this is definitely possible, right? You can do this. Anybody can do this. You just have to be disciplined about it. So one of the things that I'll share with you guys, an anecdote, is in these conversations that you'll have with people, oftentimes you'll approach somebody and you'll say, hey, I want to turn off your server for a few hours a day, right? And inevitably, one of the first questions you'll get is, well, how much does that server cost? And if it's a T2 medium or something like that, you'll say, it's 7 cents an hour. And I'll go, all right, here's $10, just leave me alone for a month, right? But that person has a small view into just that one server. Whereas I am looking centrally at the macro estate at hundreds of servers, where that 7 cents per hour multiplied by so many hours a day times so many days in a month times so many servers in the estate really adds up to a lot of money. So I was doing a training event internally for our Hess IT staff one day, and I was getting people up to speed on how to figure out what their stuff costs, how to calculate storage for the EBS volumes, how to calculate what their EC2 instances cost. And I had my manager directly sitting in front of me in the audience, and I turned to Bill, and I said, hey, Bill, I'll make you a deal. How about for the next month, you don't give me my normal salary. You just give me 1 penny on day one, right? And then the next day you double it. And the day after that, you double it again. And you just do that for a whole month, and I'll be completely happy. Will you take that deal? Bill's too smart for that. Of course, he declined. Because he knows what that ends up at the end of the month, right? I'll be walking away a very rich man. And the thing with this graph is it's very easy with this chart to show people how this applies directly into AWS world when you extrapolate from that one server that's 7 cents to potentially hundreds of servers running for many, many hours. And then you take that monthly savings and you multiply that out by 12 times, and your annualized savings are huge. So I want to talk about how we built our cost optimization scheduler that we call. It starts with Amazon S3, and we have a very simple JSON definition file that defines our schedules. Here I'm showing schedule 3, it's just one of our many schedules. This one has a series of stop times at 6 p.m. and start times at 6 a.m. So all the schedule is saying is you're starting a server at 6 in the morning, stopping it at 6 o'clock at night. And this is one of maybe 35 or 40 schedules that we've defined. They all sit in this JSON file in S3. We've got an event in CloudWatch that runs every 5 minutes. It fires off a Lambda function. And that Lambda function is basically matching up those schedules sitting in the definition file against EC2 instances that have tags on them. So on the tag, I can specify what schedule that particular server belongs to. So if it's 6 o'clock in the evening and this function fires up, it finds schedule number 3. It's going to go out and look for every server that's on schedule number 3 and say, OK, I need to stop these servers. It'll automatically stop those servers. So the key thing about doing this is you're not limited to the schedules you've already defined, right? Somebody comes in and says they've got a new request for a new kind of schedule. I just scan through my list. If I don't have one that matches what they need, I just go out and create another one, save the new file up there, boom, ready to go. And then if there are events or times where there's a heavy UAT period or some kind of release coming up and people want to opt out of their schedule just temporarily, you just go in and flip that flag from true to false, and that'll skip over it in the scheduler. And then when they're ready, you just come back in and change that back to true. So it's very easy to do that. Let me transition into the dashboards that we built using Spotfire, and I want to make a quick note to mention that all of the data that goes into these dashboards is real live data from the AWS environment. We've got a serverless process coworkers built, and basically it's making API calls to AWS constantly, and it's pulling down the metadata about the instances, the volumes, all the tags for all of those resources, and storing them into a SQL Server database. Once all that data is collected in SQL Server, I can write very simple SQL queries to build the Spotfire dashboards to represent that data in a manner that makes sense to the end users. So with that said, we'll look at the very first dashboard, which is all around one of the pillars that Sunny talked about, turning things on and off, right? So if you are one of the IT managers that owns part of the AWS estate, you can fire this up. You can come in here and you can see how many servers you own. And you can see how much everybody else owns as well. Again, this is all going back to that lean concept of making everything visible. One of the things that we were hoping to do with this is create this culture of competition, right? So if people come in here, I'll pick on manager number 9. That's the one with the blue bar, 154 instances. Manager number 9 comes in here. He clicks on that blue bar. He can see the breakdown of how his instances are across development, staging, and testing. He can then further drill down into that. Of his 29 staging instances, he'll find that 26 of them are in that true column, meaning that they're on a schedule. They're going to be shut off on a regular basis at some point. Only 3 of them are not on some sort of a schedule. I mean, that's a huge win. So for that manager to have majority of his staging instances to be shut off automatically all the time, that sends a signal to everybody else, hey, look how well this guy's doing. He's a rock star. Like, why am I lagging behind? And everybody can see it, right? So you make that very, very visible. And if this manager wants to go and see which 3 instances he has and what's the cost impact of those, then he can click on that false bar and he can get that view. So this speaks to the compute on-off part of the story, right? But then there's another pillar of optimization, which is the storage. So storage, traditionally, has been harder to gather data for in AWS because there wasn't a very easy to get neat metric that's native in CloudWatch like you get for CPU. You can get CPU utilization metrics of various different types, but there's no metric that says you've provisioned 1 terabyte and you're using 10% of it. So we had to get creative. We had to create a custom solution on how to gather that metric. I've got some details on that coming up in the later slides. But this is data, once again, that we compute on the back end. We pull it down into SQL so we can show it in the Spotfire chart. I'll walk you through this chart real quick. Down on the bottom on the x-axis, what you're seeing is from 0 to 100%, what percent of the server or the disk space is free. So ideally, you'd want everything shifted over to the left-hand side, right? You don't want any servers out there with 100% free storage. That's complete waste. You don't even want anything that's sitting up there at 80, 90, 70%, right? So if you zoom in using the zoom slider down at the bottom, then you can see everything that's kind of shifted over to the right-hand side, saying that lots of storage is free here. Now, on the y-axis on the left, you get a relative scale of how much that is, because 10% of 10 gigs, or 90% of 10 gigs may not be so much, but 90% of 10 terabytes is quite a bit. So on the left-hand side, in terms of gigabytes, you're seeing a scale of how big those servers are. So if you're coming in here, you're looking at stuff that you want to have immediately see a big impact from, then you're going to focus on the top right-hand side and work your way down to the bottom left-hand side. So in this case, if you wanted to pick out that one blue dot that's sitting up there, you can see the details around that server. So you've got a monthly cost on the free space of $225 a month. And then on the right-hand side, again, in Spotfire, you can click by manager and kind of further define what parts of the set that you want to see. So the other thing that we also want to be able to do is figure out which instances, from a sizing perspective, are not sized correctly. So Sunny mentioned Trusted Advisor, right? That's another tool that's out of the box in the AWS console that has many reports across different dimensions that tells you about problems in your estate. One such report is low utilized EC2 instances. So Trusted Advisor already does the work of identifying these instances for you. And when you go into the console, you can see them. Once again, we pull that stuff down into our SQL database. We built this report out of it. So what you're seeing here on the bottom axis for the cost of the server going from $0 up to $800. And then on the left-hand side, you're seeing from 0% at the top to it's about 16, 17% at the bottom. So the same concept applies here. You start from the top right-hand corner and work your way to the bottom left-hand corner. Those are going to be the most impactful instances for you to focus on first. So in this case, I'll click on that purple dot and I'll see, okay, here's an M4 2X large, 14-day average CPU is about 1%. So why is that an M4 2X large? Right? Is there something I can do? Can I dig in to find out what workload's running there and what's a more appropriate sizing for that instance? So by making all this stuff visible, everybody can see who's got the most oversized instances and who's doing the right stuff, right? So we want to keep doing this kind of thing more and more. And one of the great things about capturing this data on a regular basis, because we pull this down all the time. So over time, you're able to trend this, right? You're able to see, are you moving in the right direction? Are you correcting these things, or is this a problem that's just perpetual, that's ongoing all the time? So I'll show you one of the examples of a report like that. We have something like this for all of the reports that I showed you previously. This one speaks to disk utilization, right? So when we started out, we were actually even higher than this, I think. I'm focusing on the last few months here. So at one point, we were closer to 64% free across the entire estate on our provisioned disk usage. And over time, iteratively, we've been able to drive that down, and now that's closer to the 50% mark. So by gathering these metrics on a regular basis, we're able to create charts like this that let us know, let the management know that, yeah, in fact, there is some progress being made. There is work being done both by the cloud team as well as the IT owners to continue to drive down these costs. So I want to show you quickly how I go about gathering these disk utilization metrics. Again, everything is serverless as much as possible. So we have an event in CloudWatch that kicks off a step function. For those of you that aren't familiar with step functions, it's an orchestration mechanism for multiple Lambda functions. So you've got branching logic or conditional logic or sequential logic for multiple functions that do different things, you can use step functions to tie all those together. So we've got a CloudWatch event that kicks off a step function. The very first Lambda it runs goes out and injects PowerShell into all of the EC2 instances. And that PowerShell basically says, calculate the disk usage. Figure out how much is free versus how much is provisioned. Store that off in Dynamo. Once that's done, the next Lambda function will just go ahead and grab that stuff out of Dynamo, put that into our SQL database. This is the same SQL database that has all of our metadata about our instances and tags and all that kind of stuff. So once I have that, I'm able to create that really nice and pretty graph in Spotfire. So that's a little bit about the cost optimization challenges, how we address those. Let's talk about how we address the operational and governance challenges. So the goals here are be proactive. We want to know about problems immediately as they happen, or even avoid them if we can. We want to automate as many things as possible. We don't have endless supply of labor, right? We want to be able to automate as much as we can. We want to reduce waste, again, going back to the lean principles. And we want to raise awareness of the cloud capabilities. So at the end of the day, I don't want to go home doing this every single day. So how do we address this? On the error detection side, for status check failures, those aren't you that aren't familiar with it, EC2, there are some default status checks that are constantly checked by AWS, and you can see them in the console as pass or fail. There is an error recovery option automated by AWS that you can use. What we felt that worked for us in our environment was to create a support ticket for the service management team, letting them know that there's a problem with a particular instance. So we've got something that goes out and checks this all the time, and it sends an alert and also creates a ticket in our trouble ticket system. The restoring of volumes, there are a couple of really good use case scenarios for this that I'll show you in a later slide. That has been automated. We create snapshots. Obviously, once you've got 500-something servers out there with 1,200 plus volumes, you've got to have snapshots done every single night. We have a Lambda solution that does that every night. And then, of course, you want to clean up the old snapshots. You might have different retention periods for production versus non-production workloads. So we have a process, again, Lambda, that goes out and creates that or cleans those up. We have service limits that we get alerted to. By default, for everything that you do in AWS, there's a soft service limit that AWS puts in place to kind of save you from yourself, just in case you might accidentally run something that just charges you tons and tons of money. So in our case, we're moving pretty fast. We're migrating lots of workloads. We don't want to come to a point where we're ready to move something or ready to start up a new type of server, and it says you don't have enough capacity because you've hit your soft limit. So we want to know when we're approaching that limit before we actually do. So this thing alerts us to it. And then, of course, the enforcements of tags. Everything that I've showed you in the dashboard relies on really, really good tags. So you've got to have those propagated everywhere. You've got to have a compliance report that tells you where you're out of compliance on that. And then for the cost governance piece, I've already kind of talked through a lot of that stuff. Security, we wanted to make sure that we highlight things like secret access keys that are out there that are provisioned that haven't been used for a while and disable them in some cases. S3 buckets, this is a sore point for some companies that have accidentally left access open to the world for S3, and people are able to come in and see their stuff. So we want to, again, detect that. We want to search for that, send us an alert, say, hey, you've got this bucket that's out there and that's open. And then on the culture part, we did a lot of stuff with our AWS account team to get people trained up in our organization. We sent them to external training events. I mentioned earlier I did some internal training events myself. One of the cool things that we did, I'll quickly mention this, we were at lunch one day, myself and the migration team, and we were joking about how we were putting in all these automations, and somebody on my team said, pretty soon you'll be able to say, Alexa, migrate my server, and it'll do it for you. And so this was around March or April of last year when the Amazon Echo and Alexa had just come out. So that weekend we went out and bought an Alexa, and we created a really cool skill that allowed us to ask very specific questions about our AWS environment. So you could say, how much storage do I have that's just sitting out there, not attached to any server? And it would go out there and figure it out and tell you in dollar amounts how much money you're saving. And the really cool thing with that was then the next step we did was actually ask it business-related questions. How much oil did I produce in North Dakota yesterday? So this is something that is not necessarily used in a production environment on a day-to-day basis, but it is something that we can show the rest of the organization to talk about the art of the possible with the cloud. These are things that you couldn't do before you were running your stuff in an AWS environment. So that's really cool. The restoring instances part that I alluded to earlier, there are two specific scenarios where you'd have to restore an instance. One is there's some sort of data corruption or the instance has failed and you've got to take a backup snapshot from the previous night and then create new volumes from that to make your instance healthy again. The other one that we found was a lot of times the servers that we migrated early on, especially, our default choice for EBS was GP2, General Purpose 2 SSD volumes. And we found out later that that's over-provisioning. That's another dimension that we should have taken care of earlier. So how do we then go back and address that? Well, you have to take a new snapshot. You have to spin up the volume from that snapshot. There's a lot of clicking around manually in the console that you have to do to address these things. So we created a step function. And this is how you go in. You go in the console. What you're seeing here is a history of the past runs. You click on the new execution, and you just give it some parameters. In this case, the instance ID. That's the only required parameter in here if all I'm doing is the first scenario where I'm recovering from previous night's snapshot. The second two parameters are not required. But then if I want to go ahead and switch from the SSD to a magnetic type volume, which is cheaper, I can provide those other two parameters. Once I've done that, I just let it go off and do its thing. And it's run off and it's done all these clicks, snapshots, backups, restoring the volumes, all that I would normally have to do manually in the console, potentially with a high error rate because you have to make sure you copy the right snapshot ID, the right volume ID, attach it to the right instance ID, all those kinds of things. But this automates all of that for me. So that's another really cool serverless use case. The last thing is self-service provisioning. I talked about this earlier in my talk. One of the challenges that we had with our old process for getting new servers was that nobody knew where to go to request one. There wasn't a really good guidance provided from our central infrastructure team to say, here's how you request it in the cloud. I think there were old management processes for when you had to go procure it, you had to give a cost center, all that kind of stuff. People understood that. But if you're in the AWS world, who do they call normally? Just, hey, cloud guy. You know, I'd get an IAM from somebody and say, hey, can you give me a server? So I wanted to improve that, right? So the goals were a very simple one-page form that anybody can understand when they need to request a server. I needed to have an approval workflow, right? I don't want servers built without me knowing about it because I'm ultimately responsible for taking care of the whole estate. So this is the reason why, and then no login to the console, this is the reason why we chose not to go with the native solution from AWS, which is Service Catalog. Because for the end user, I don't want to go create a bunch of AWS logins just so they can go in and see the Service Catalog, right? We want to give them very easy access to this stuff. This has to be accessible from the internal network. So we want to lock it down so you can't request it when you're outside. Of course, the EC2 instance that you build has to be joined to the domain. You have to have local permissions. And then all the standard tools that we use for management have to be installed right out of the gate. We should have very, very quick turnaround time. Again, staying true to that agility concept of the cloud. And then finally, I wanted to make it serverless, right? This is something that's not going to be used all that often. How many server requests am I going to get? Once a week, twice a week, 3 times a week maybe? Why would I want to build out a whole server just to request servers? I want to make it, ironically enough, serverless. And I wanted to do this very, very quick in an MVP fashion, right? So I didn't want to spend a whole lot of time gold plating this thing. Here's what it looks like from an end user perspective. They go to this page, they see all the requests there. That's pretty much the end of it. Down at the bottom, it's kind of cut off a little bit in the screenshot. But that's the request button at the bottom. They fill all this stuff out, and they submit it. And I get an email that says somebody's submitted a request. I'll click on that link to go see the details of that request, and I'll approve it. Once I've approved it, I've got a step function that goes out and does all the things that need to be done to build a standard EC2 instance the way that we want it to be built. It's deployed to the right VPC, to the right subnet, has the right security groups on it, has all the things on it, the tools that I talked about. And at the very end, it sends a notification back to the requester saying, here you go, here's your server. So we've been able to take this kind of convoluted process that potentially took weeks to get through and turn that around. If I'm actually at my desk when this request comes through, in less than an hour end to end, from the time it's requested to the time that it stood up. So how do we make this happen? I'll show you the architecture diagram behind this thing. It starts with an S3 bucket, which hosts an HTML and JavaScript file. And that bucket is locked down to just the corporate network, so you can't access those pages from outside. Once that submit button is clicked on there, the payload, all the data fields on that page are submitted to an SNS topic. And the subscriber to that topic is a Lambda function. So as soon as that topic gets notified, it's going to kick off the Lambda function. That Lambda function will send a confirmation email back to the requester saying we're acknowledging your request, and then it sends that approval email that I showed you to me. Once I get that approval email, I click on the link, I load up the page. I've got two options, right? I can reject the request. I can say, nope, I'm not going to give you the server. And what that does is basically sends that notification back to the requester saying your request has been rejected. Or I can be nice and I can approve that request. And in this case, it sends the notification to a different SNS topic, kicks off a Lambda function, stores all the data, and then that Lambda function will kick off the step function. And in the step function, I'm going to go through all the various steps that are required to build out this server. And at the very end of that is finally the notification email back to the requester saying, here's your server, it's ready to go. So I've shown you a lot of stuff that we've built using a lot of these serverless technologies, trying to stay true to what's coming ahead, right? Not perpetuating the problem of not matching the capacity to the demand. So how much would you guess I spend on AWS Lambda in a month? It's actually not as much as you would think. It's very, very cost efficient. I'm prohibited from sharing actual dollar amounts. But all I'll say is Fry would not be holding dollar bills. So in summary, what does it take to make all of this stuff work? You've got to have the architecture for cost at the forefront of your mind. We have an architecture review process where we review any new build request. So that build request email, when it comes to me, at that point, I've already kind of been notified that there's a project coming in play that's going to have some compute requirements. And then optimization responsibility. We want to give those tools back to the IT managers and estate owners. We want to make it easy for them to see how much their stuff costs and make them take some responsibility for right-sizing and for turning stuff off. Budgeting and approval, right? I mentioned that approval workflow was real important, so I need to have an overall view of everything that's being built into the estate. Tagging with the stakeholders is real important. None of the stuff in the dashboards works without proper tags in place. So we have to have some automation around addressing that, right? So I mentioned earlier the automation we have about generating a compliance report. We can see that, and we can take actions based on it. And then the metrics and targets, right? So one of the things that's missing in what I talked about was the RI conversation. And that's purposely missing because that's something that is done as a layer on top. So I don't put that responsibility back on the IT managers because they don't necessarily have a view of the entire estate, although they do in those dashboards, but they don't know what's being under-provisioned, what's being over-provisioned from an instance type standpoint. So once they've done their job of turning stuff off the way it needs to be, right-sizing things the way they need to be, then I can come in and I can look at that entire estate and say, here are the RIs that make sense for a purchase. This is what I'm going to go out and purchase. And then the path forward for Hess is, we're not done with our migration. Like I said, there's still a few more workloads left. We're going to continue to move those things. We're going to continue to look for ways to optimize our environment and drive this serverless adoption and get people trained up and get people to understand how to build cloud-native applications and do some more improvement around our governance. We are going through an onboarding to a managed service provider right now, so the skill sets that they're going to bring in-house are going to help us on this journey. And with that, I'll hand it over back to Sunny to close up.
Cool. All right, before we get into questions, I'd like to thank Haider a lot for sharing the story. A couple of reminders, I saw people taking pictures. All sessions, as this one, are recorded on YouTube, so they'll be available for you. And please don't forget to complete your evaluations as well. With that, I'd like to thank you for your time, and we'll open up for any questions.
Can you share any details around the tooling you use for the lifting chips ever? It's been custom.
As much as possible, we've used greenfield integration. So we tried to do greenfield as much as possible, build up the EC2 instance and install from scratch. It doesn't work all the time for legacy workloads where you don't have the capacity to understand what exactly is going on because the resources are no longer there. For those, we've used a variety of tools. There are some third-party tools out there, and then Amazon has a tool called Server Migration Service that hooks into your vCenter environment, and it replicates that server over. You can also do VM export-import, where you take the VM full-on image, export it, move it over to the AWS environment, and launch a new image from it. Yes.
Thanks.
Can you talk about what you're using to enforce your tags?
What we to enforce our tags? It's really custom stuff right now. So we have Lambda functions, again, that go out and look for things that are out of compliance with what we want them to look like, and they generate alerts based on that. And so we just chase up on those people and say, hey, what's the intention here? The great thing about provisioning through an automated process now is 99% of the time the tags are right out of the gate. We don't have as much of a problem with it anymore.
What about error handling? How are you, if you're orchestrating a request into a build and something fails, what do you process with that?
There is an error handling routine in there that sends notification to the cloud team, so we can take a look at what's happening there and then address it before we complete it all the way through.
I think there was a question here earlier. No?
Yes?
Before building all of your enforcement and compliance and whatever Lambda is, did you look at any tools?
We looked at AWS config, and we did use it. There were a couple of challenges with that in our specific environment. I think it's improved over time. You'll find that a lot of times you'll get things out of the box that are very early release that may not be what you need at that moment in time. So you should be very aggressive about seeking other things. But over time, they will improve. So we may be at a stage now where we can go back and look at AWS config, and whatever was missing a year and a half ago has likely been addressed. And we might do that at some point.
Yep, go ahead.
Can you share how your disaster recovery plan has changed?
So it hasn't changed a ton. I mean, we are built out with a VPC in a single region, but across multiple availability zones. So we've documented the steps that would be required to take the backups that we create every night and stand up the new servers. But we have a lot of work to do on that end specifically, to be honest. Yes?
Talk about your backup tool of choice. Is it a custom thing?
It's the custom Lambda function, yes, pretty
Yeah.
much. We've been doing that for 2 years. It's evolved. We've had a few hiccups here and there. What you'll find is as your estate grows, you will have to, if you have a custom homegrown solution, you will have to go back and tweak it a little bit, because what works for 50 volumes and 10 instances may not work exact same level of reliability when you get to 500 instances and 1,200 volumes.
Yeah, that's a great question. There's a lot of question around the tooling, and one of the overarching themes of this presentation is about being able to leverage the native, open, and flexible AWS platform, right? For any of these things, there's a number of tools out there. As you walk down the expo hall and the marketplace, you'll figure out. But the real value that Haider and the Hess team figured out is how easy it was to leverage the flexible platform through the APIs and build the tools. They're not a huge development shop. They do a little bit of .NET dev, but he's familiar with that platform. He just got the SDK, started building Lambda functions and building these applications on their own, right? So, we could have, gone out and procured a tool for each one of these. My favorite one actually is the self-service provisioning one. The conversation initially started with him going that route and me coming in saying, hey, how about have you looked at Service Catalog? And we talked about it. He said, no, it doesn't have this feature, this feature, this feature. Okay, makes sense. How about CloudFormation backing it? He said, I would rather go the Lambda route. And then the true enterprise way to do it is what? Hook it up to something like a ServiceNow or something like that. Even though they had plans of that, that was a 12-month effort. And I think he built this tool in a week.
Yeah, it's a little over a week.
A little week, yeah. All right, I think we're just out of time. We'll be out in the hallway if you guys have any more questions you want to talk through. But again, once again, thank you so much for attending, and have a great rest of the conference. Thanks, guys.
Thank you.